And we have an amazing topic to talk to you about. This is the OpenShift service mesh on multi-cloud environments. But first, a little bit about us.
So I'm Paul Pindell. I work for F5 Networks. I'm a senior manager of architecture and engineering in our business development group. And along with Dylan and David, we built, there we go, a little loud. We built a demo. We're going to show you a couple things on it. And go ahead, Dylan.
All right, and my name is Dylan Turnbull. As you can see, I'm a principal business development, engineering, cloud networks, and a few other things. I really just live in a little black box most of my life. So I, along with Paul and Dave, built this architecture with several of our other colleagues. And
David Kane, I work for Red Hat. I'm in the Global Partners and Alliances organization, and I work with partners on building repeatable assets, one of which we'll show you today.
all right, so obviously the topic we're going to be talking about starts with multi-cloud, or some of you might call it hybrid cloud. Really, it's gone beyond hybrid. It's more than just one, so hybrid kind of goes out the door. So we're going to be showing you multiple clouds. It kind of started with a little idea. Here's the goal: deliver multi-cloud web application architecture using F5 Big IP, LTM, and DNS, the F5 Big IP controller for OpenShift, as well as the F5 Aspen Mesh Istio. A couple of those guys are in the room with us today. We wanted to deploy all that into OpenShift, several OpenShift clusters, and on our own F5 infrastructure. And we did it all with Ansible Tower, running on-premises in Azure and in AWS. So it kind of started with this little idea here. And we thought if we could take all these and run them through that, right, we might just be able to do this. So when we discussed this back at KubeCon in November, that's what it really felt like. A bunch of guys sitting around a big table, rolling dice. And this is what we ended up with.
All right. So initially we started with the idea that we knew it had to be multi-cloud. And we knew it had to be multi-cloud because that's the marketing term that's out there. We've presented this at several other places. I presented it at a couple of Red Hat user groups. And in order to get marketing dollars, we had to put multi-cloud in it. But multi-cloud paid for beer. So multi-cloud is the name of the game here. But multi-cloud, we're delivering this in several different places, and we'll talk about that. We knew we had to use Big IP. We're F5 Networks. We knew we had to do that. We knew that we were going to run this on OpenShift container platform. We knew that we were going to use our controller. So F5 has built a controller that runs within OpenShift. That controller listens to the API gateways, or the API servers within OpenShift, looks for changes, and affects config on a Big IP device. So we're using that controller. It helps, it brings things together. We were going to do this on-premises. We're going to do it at Microsoft Azure and AWS. So we're going to show you that. We're going to show running OpenShift in those three environments, Big IP in those three environments, and we're going to tie them all together. We're going to use an enterprise e-commerce app to show this off. 3 enterprise e-commerce apps. We're also going to use our Big IP DNS product. So Big IP DNS is a product that is an intelligent DNS server. It takes your business logic and then will answer DNS queries depending on your business logic. So we're going to show what that looks like. We're going to have Big IP DNS rerouting connections based on what happens in the environment. We're going to use IAPs. IAPs are an F5 technology that allows us to post a declarative configuration to a Big IP device. We tell the Big IP device, we want you to kind of look like this, and it goes and builds that config on the Big IP. We used another tool, TMSH to IAP, to build those IAPs. We're using iRules LX. All of this is built on RHEL Atomic Host in the on-premises environments, and we're using Ansible Tower to deploy it all. And finally, we're going to showcase Aspen Mesh, which is an F5 incubation of an Istio services mesh. So, how many of you have ever been on stage, about to do a demo, and had to make sure that you were praying to the demo guys and make sure it was all working? How many out there have done that? Okay. How many have had it fail? There you go. We're going to use a little video magic here, a little Julia Child's magic. We're going to do some preparation work. We're going to put that in the oven, and then we're going to take a fully baked one out of the oven and show you what happens. We're going to do that with videos. So we had an issue the first time I went to present this in New York at a Red Hat user group. Friday night, Dylan and I, we had finished. We got everything set. It was perfect. And we said, Monday morning, we're going to get up and we're going to record those videos for Tuesday. Tuesday at 2 o'clock, I had to present. Monday morning, we wake up. No one can get in the lab. The lab is down. The environment that we're using is down.
Not this lab, the whole lab.
The whole thing was down. And it was a catastrophic storage failure. So we had a controller go out, and we lost half of the storage that we were using. And it took us several hours to figure out what was going on, several hours to bring the storage back up, figure out that we needed to fail over to the other controller, wait for everything to come back online. We were on a WebEx for, I think, 18 hours that day, getting it all figured out. But by midnight, we did. And the thing that rescued us was Ansible. Once we got the storage and everything built back up, we had done the work of creating the Ansible tasks, the Ansible roles, and the playbooks to respin up each and every environment in a matter of minutes. And so we'll show you here in just a second a demo that goes through that creates one of the 4 environments that we've got. It does it in about 5 minutes, but we're going to use some video magic to shrink that down to about 30 seconds to show you what happens, so you don't have to sit here and wait for the Ansible log to scroll by.
I'm going to invoke the time stone for that one.
There you go. So, and I had a big crew behind us. So Dylan and Dave, and then there's a lot of others, some in this room, some in other countries, that helped behind the scenes making this happen. So here are the components that we've got. We've got OpenShift running on RHEL Atomic. We're using Ansible Tower, Big IP. We're using the Big IP controller for OpenShift. We're using Ansible playbooks. We built those, iRules LX. And the goal was to take all of this and with the click of a button, be able to deploy it all in each of those environments. And we succeeded in that. So I'm now going to show you a video of how we deploy this, or it being deployed in OpenShift with Ansible Tower. So here we are. We've got our Ansible Tower and OpenShift. We're going to go take a look. The first thing you do in any of these demos is make sure that we're not cheating. So we're going to show you that there really isn't anything going on in this environment yet. We've got the applications deployed, but if you go look at the config maps, we don't have the config maps that tie the configuration back to the Big IP devices deployed. So we'll deploy those in a minute. We'll go look at kube system, and we'll see that there's nothing deployed there. In a minute, we'll deploy the Big IP controllers into the kube system namespace. Next, we're going to look at the Big IP and make sure there's no funny business there. Just a second, we'll look at the network map. There are no objects here. We'll look at the partitions. There are no partitions created yet. Move on to looking at policies. No networking L7 traffic policies. And the network is clean. So no self IPs, no VLANs, no VXLAN tunnels. None of that is created. All right, next we'll go to Ansible Tower. This is Ansible Tower. Within it, we've got several different projects that we're using. The one that we're going to work on is the multi-app project. These are the variables that we've set in there for that multi-app project. We're going to go take a look at the inventory here in a second. We've got 4 different inventory groups. One inventory group for each of the clouds that we're deploying. AWS, Azure, on-premises 1, and on-premises 2. Within that, we've got different templates that we're using. We've got a cleanup and a setup for each and every environment. So we're going to run the setup for their on-premises 2 environment and the Ansible rulebook. And here's the Julia Child's magic. We're going to speed that up so you don't have to watch for 5.5 minutes as that goes by. We're doing several different things. We took and made a template that worked in all of the environments and variabilized it. We created some var files so that when you run this, you can take this. We wanted to add a third cloud, a third public cloud. We could easily do that just by creating a different vars file and specifying the variables that are specific to that on-premises cloud, the IP addresses of the management ports, the username, all of those pieces and parts that you need to have at runtime. we specified those in the vars file.
You can use the same playbook.
And we use the same playbook,
Yeah.
just different vars file to run it.
Yeah, there's some JScript that basically takes some TMPL versions of the playbooks, and as you create a new vars file, it reads into the vars file and then generates all the playbooks for the next data center. So we wanted to make it as simple as humanly possible to add data centers. So we variabilized as much of the playbook runs as we could, and then wanted to be able to feed those in in a template manner.
Yeah.
So.
And this is what made it so easy, that 5-minute, once we got our storage back, 5 minutes for each of the clouds, boom, and we were back up and running and everything was working. And then it took us a couple hours, 3 hours to record the videos and get them ready for the demonstration I had the next morning. It was a very long day, lots of people behind the scenes making it happen, but Ansible was a necessary tool to get us recovered and back up and running.
Yeah, he went on stage, I went to bed. So, so let's take a look at the architecture in a little more detail. So each one of these cloud environments, so the on-premises environment actually houses multiple different servers. We've got the big IP DNS. Now, in most models, you would not use a single DNS. This is for testing only. In a more production-ready environment, you might see a big IP DNS sitting in either another data center, so you can add HA, or one in each, so that you can do HA failover between your data centers. But for testing purposes and to keep the pocketbook down, we put the DNS inside our own lab. We've got a local traffic manager that sits inside of each data center, and it's responsible for monitoring the traffic that's happening in and out of the OpenShift clusters. And then inside each data center, we've got an OpenShift environment, and there are two that are built off of Atomic, 2 that are built off of just RHEL plain, and I think there's one, is there another one? It's just 2 Atomic and 2 RHEL plain, yeah. And then, of course, we have an Ansible Tower server that's sitting inside the on-premises location. And then to keep it all running, we've got OpenShift, and sitting in OpenShift, as he's mentioned, we have the container connector that's watching the control plane and giving us traffic, or giving us information or into the big IP about what's going on inside the applications that we have deployed. And then we're using Aspen Mesh, which is Istio at its core, but it is a enterprise-grade, fully supported, hosted service that gives you essentially, with very little configuration, instant access to all of the fun stuff that Istio offers, the telemetry and things you can do with Jaeger. We'll take a look at that in a little more detail in a little bit. So that's what we built in the environment. So if we look at just general ingress, so as things are coming in, you get an HTTP request that comes in, it hits the big IP DNS. I was told this has like a laser pointer, and it does. Awesome. And it hits the big IP DNS, and that actually is reading from the big IP LTMs, which in turn are getting information by way of the big IP controller through each OpenShift cluster. And when you look at this, the big IP controller matches all the services that are deployed in your applications with pool members that are attached to virtual IP addresses inside the big IP. So the nifty thing about this is once you've set this up and you spin up pods to accommodate load, it automatically adds new pool members to the big IP, and so it's set it and forget it, and it does its job. And then, of course, with Aspen Mesh involved, you can get proactive notifications on the health of your mesh and the health of your services. So if things go out of whack, you can see that your health status will go yellow, and you can go take a look at what's going on. So from the data plane point of view, we're pulling, like I said, we're pulling information out of the actual deploy. There's one version of each application deployed in each cloud. And there are 3 applications, 2 e-commerce application and Istio's book info. And we essentially are monitoring those applications, pushing that up to the LTMs. That goes to the big IP DNS, and that's how we're essentially allowing essentially global server load balancing from our big IP DNS to all the various clusters that are in play. So that's the full architecture. So what does that really look like? So let's take a look at what our failover demo looks like. So I might have to stop it a little bit here. And do we have to click it once? There we go. So each one of these wide IPs is essentially associated with a service inside OpenShift. So this gives us, at a service level failover per, I'm going to pause it for a second. Oh, it didn't work. Let me go back, do this. No. You got to click in there. Okay, thank you. All right, I'm just going to roll with it then. All right, so we'll let this play through a little bit. But basically, each one of these correlates to a service inside the application. It gives us the capability to do a per-service failover. So if one service fails in this cloud, we can automatically fail over the traffic to that service to a different cloud. Which becomes very valuable if at some point in the future you want to do a service-to-service failover. So if you wanted to steer traffic in various directions, you could do that using the technology that we've got set up here. So this is basically just going through and very quickly showing you that we have each of these deployed in each of the cloud environments. So there's our EC2 environment. There's our Azure environment. And then we're going to go ahead and go take a look at this last service, and then take a look at what's going on in the big IP. So each one of these pool members correlates to a service or an application service inside OpenShift. And to kind of demonstrate what happens to emulate a service failover, we're going to kind of go through and iterate through all the different environments to show that all the big IPs are set up correctly. And then we'll go ahead and hit the first website. So we're going to go right to the main link. That gets us to on-premises 1. Shows us where we're at. And then to emulate service failover, we'll spin down the pod. And then once that's complete, we'll check out what happens in the big IP. You can see that that's almost immediately reflected inside the big IP. And then the big IP notifies the DNS server that it has a service out and immediately fails over to the other cloud. So it's pretty quick. Couple of refreshes. Right now it's using Node.js, and I'm just going to go through a few more of the sites to show you that you can do this with any of the data centers.
But also, the actual URL didn't change right there. I don't know if folks caught
Correct.
that right there.
Yeah, correct. So the URL does not change, just the data center changes. And that's all happening by steering the traffic inside the big IP to the appropriate data center using our global server load balancing technology. So we're running through the rest of the clouds just to show that that's happening with all of them. And then we'll spin them all back up. And then once they all come back online here real quick, and again, we're using some movie magic here to make things go a little faster. We'll check the big IP. All the pods are back online. Everything looks kosher. We'll check the rest of the pods. And then ultimately, we'll take a look at the actual site. And as you can see, once we hit that link again, we're back to the on-premises 2 deployment. So almost immediately, you're able to fail back and forth. So an interesting story is when I was originally configuring this, I needed to upgrade from 3.5 to 3.7. And I rolled the whole upgrade from cluster to cluster to cluster to cluster, never lost the website, not once. So. And this is just basically showing on a per data center basis that all the data centers are back up and running and serving pages. And failover is doing what it was intended to do and showing us all the sites that we need to get to. All right.
So we saw from the infrastructure standpoint, going to the same web URL, but going to different environments right there, focused a lot on that. But what about in the individual applications themselves? Remember, we had 3 separate applications on there. One thing, I don't know if you've heard too much about Istio or a service mesh inside of OpenShift. Really, the parallel here is when we break up a lot of our applications into microservices, how do we actually tell which microservice is talking amongst one another from the operator standpoint? We have a slide, 2 slides from now, where we talk about what it does in the actual application itself. But Istio itself is installed on OpenShift, and we kind of break down a control plane aspect, which Dylan was alluding to that earlier, where in Kube system we run the Istio control plane right there, which has a traffic management component, a management infrastructure, but is also an authorization. You see that at the top right there. But really what we do in the individual application right there, typically we have only one container per pod in OpenShift. Well, in order for us to get that visibility into the application itself and look at things like circuit tracing, analysis, just how are these individual microservices, how can they talk amongst each other? Because we have relatively complex apps that may have multiple microservices that talk amongst each other. And so a parallel here for the networking guys in the room is a software-defined networking. So on an individual host, we have a vSwitch, and then we have a controller right there. We're doing a similar parallel in the microservices world with Istio here. So that's from the operator side. What about from the application side of it? What does it actually do to the pod?
All right, you're going to go through this part of there.
Go ahead.
All right. So basically, this is where Aspen Mesh would come to play. If you take a look at the area on the left, this is kind of the world that we've been living in, right? You've got a whole bunch of different tools that each individual application developer has to use to be able to augment whatever application it is they're developing, which is, you know, when you're talking about this happening at the scale of a large corporation, keeping all this in check can be arduous, I think would be the word I would use. There's probably a couple other words I can't say in a public forum. But really what this does is it relegates it to something much, much simpler, right? And what we've done with Aspen Mesh is we've essentially taken that, which is Istio at its core, and then we've abstracted all of the visibility aspects of it and then and put them in a hosted portal.
Well, yeah, just so to add, so instead of building that application logic like SSL termination into each one of your individual apps, like on the left-hand side of here, we're actually relying on the service mesh to take care of that for us. Because our application developers really want to focus on building differentiated value in their business logic portion of their application without having to think too hard about encryption or service tracing or failovers and stuff like that. Let the service mesh handle that.
Right. So where Aspen Mesh comes in is we essentially take so when we take a look at this, you can see that each of these is representative of a pod, and then we're adding Envoy via Istio, Mixer, and there's one other component that's not reflected here, but it's in the demo portion. And then we add in an agent, and the agent essentially takes the communication that's coming out of Istio, all the telemetry and the data, and then it pipes it out to a cloud service, a software as a service model, and it allows you to visualize that data through applications like Grafana and Jaeger, as well as it adds some of its own capabilities to do things like showing you the health of the service mesh and whatnot. And all of that is through a single login portal.
And Dylan, I think the important icon there is the little headset. It's a fully supported solution. It will be a fully supported solution from F5.
Which brings us to this slide.
Oh.
So the big benefit is it is a fully supported enterprise-grade version of Istio. It's served through a portal. It gives you the visual insights through its dashboard. It gives you logging and tracing inside the activity in your service mesh. It's served hosted as a service platform. It's fully customizable, has fully customizable alerts and events. And of course, all of that is handled through a security token, authentication, and then, again, fully supported. Which brings us to the Istio Aspen Mesh demo. So right now, it's available. You can go out to the website. If you want to send us a message, you can. All right. Is it going? Yep. Okay, good. It's in early access right now, so you can go ahead and click that link and get early access. And to get started, it's relatively simple. All this documentation is out there. It's very similar to Istio. You go ahead and grab the bits off of the Aspen Mesh website, unpack them, add it to your path, and then run that command line to install the main Istio YAML. That will establish an Istio system and deploy the Istio CA, its ingress, its mixer, and the pilot directly into Istio. And then you will have to enable initializer. Now this has changed in 3.91 and .7 of Istio, but it essentially is the same thing. What it does is it gives you the ability to automatically load sidecars into your existing applications. So in order to enable that, all you have to do is grab that token. That's actually my token, but the guys at Aspen Mesh said that they were going to change that for me because I didn't grade out. And like I was saying, you can get health status, services in the mesh, as well as warnings that kind of tell you when you're doing things that might be questionable inside your services. It shows you the connectivity between the different services in your web applications, as well as giving you health checks inside those services to tell you, am I hitting what I would like to do? In this case, my requests aren't taking any longer than 331 milliseconds per request. So I need to get to the point where I can pause it. There we go. Perfect. All right, so the first thing I'm going to do is kind of go through what a Jaeger trace is, but to kind of set the stage for that, why did it do that? That's crazy. Now you're going to have to forward it now. There you go. Oh.
Forward.
Last day of the summit.
Yeah. Had to have some wrinkles.
I think you were there.
Yeah, there you go. Just go to Jaeger. I'll just talk through it. That way I don't have to worry about it moving forward. So basically, this is what we're used to seeing. So a GET request comes in for whatever page you're trying to serve. We see the whole shebang all the way through 260 milliseconds. What Jaeger gives you the ability to do, Jaeger plus Istio gives you the ability to do, is take a look inside the actual service mesh itself and then break that request out into what's happening inside the service mesh. So for instance, and I'm going to go ahead and run a quick trace and show what's happening inside that service request here. So if you're running into an issue where QA pokes you and says, hey, you're producing errors, and you can ask them for a trace, and you can get full visibility into where specifically that's failing inside your environment. And more importantly, in the multi-cloud environment, it will tell you what specific cloud you're failing in by looking at the URL and the header information. The benefit of that, anybody who's tried to trace something down without this level of traceability knows that unless you have the full tooling and it's working awesome, it can be very difficult to get this level of tracing to try to determine where your failure points are occurring. So here's an example of a standard request. I just did a couple of refreshes over there to generate some current traffic. As you can see, it's taken about 126 milliseconds. So to emulate a failure, I'm going to use an injection that will inject about 300 or 400 milliseconds of latency into the rating service.
So you're intentionally trying to make this slow, so you
Correct.
can see where
Yeah.
the traffic communication is going and why it's being called, why it's slow.
Exactly. And so I'm just going to generate a little more traffic so that I can see a current trace. We look in, and then once we're done generating that traffic, we'll go ahead and jump back over to Jaeger here. Keep the same values, run the trace. And if you look all the way down there, you can see everything is north of 331 milliseconds, which blows my time windows that I want to keep it under. So now that I know that, I'm going to go ahead and find that mistake that happened and unmistake it. And then I'm going to go ahead and run a couple of more instances just to double check that I've solved my problem. And then we'll take a look at another Jaeger trace to see that is no longer happening. So as you can see, everything's back down to 111 milliseconds, which is well within my window. I fixed my bug. I checked my code in. I run my Jenkins, run it through Jenkins, and then wait for QA to come back and tell me something else is wrong. So. All right. And that's basically what Istio offers, or that's one component of what Istio offers, to be more accurate. All right.
Very cool. All right, so I want to just take a few minutes and share with folks just some of the things that we've partnered with. Red Hat and F5 have worked together jointly on from a solution standpoint. And just a little bit about Red Hat. I think we're running just a little bit short on time right here. From a technology side, Red Hat is a full stack portfolio company. We have everything from operating system to middleware to software-defined storage to cloud infrastructure. But I don't think for a lot of customer-specific use cases we can do everything on our own, and we have a very, very robust partner ecosystem. So we've partnered up with F5, and everything that you've seen here today in demos, all from deploying the infrastructure and the applications in 2 on-premise data center environments and 2 cloud environments, to getting visibility into the individual microservices and seeing everything in a consolidated portal with a tried and true enterprise leader, F5, in that space. That's the benefit of partnerships and solutions that we bring to market together.
Sure. Go on to the next one. The next one this is just an overview of the different solutions, the solution areas. So we did not talk about it here in this session, but we do have certified OpenStack solutions. So we have LBAS plugins that are certified on various versions of Red Hat OSP. And we have our containers are in the Red Hat portal. So they are certified there, and they're graded, and they're in that portal. And we've got, at this point, we have 62 upstreamed Ansible networking modules that are upstreamed into Ansible Core. And you can go get those. They're fully supported by F5. You can download them, use them, and we will support you with those modules. We have, and that's in Ansible 2.5. 2.6, which is coming out in a month and a half or so, from what I understand. Don't hold me to that. When it comes out, it will have another 30-plus modules in there. So we're hoping to get north of 100 in the next release of Ansible. So as we wrap up, some of the things that we learned. We learned this because of the failures we had, the storage failure we had in that very long day. Automation is key. Without automation, without Ansible automating what we were doing and how we were delivering and deploying these solutions, without Ansible able to back us up, we would not have been up and running, would not have been able to meet our commitments and present at the conference that we were at 3 weeks ago. So it's incredibly important to be able to make sure that you're keeping track. Your automation, as you're building your solutions, build the automation to go along with it. That way, you can always recover back to the state you want to be in. Don't build an entire solution, then go back and try and automate it. As you're building your solution, we found build the automation to get you to that point as well.
And if I could interject there, one of the things I found incredibly useful, he said, as he kind of touched on, is starting with your automation at the beginning. Not only do you need to keep the automation going, you need to keep it lockstep with your changes. So every time you make a change, every time you make an adjustment, you need to update all your playbooks and keep everything lockstep. You never know when something's going to, like you said, a controller is going to fail. And because we were keeping our playbooks lockstep with our environment, the recovery was incredibly fast.
Yep. And we talked about this earlier, but make sure that you're writing your playbooks and your roles to be good use of variables, so you can reuse them in different places just by changing a vars file. Multicloud is here. It is here. People are using it. It doesn't matter if it's cost that's driving. It doesn't matter if they're doing it for failover. It doesn't matter if it's just because they want to run the right service in the right place. Multicloud is here. People are using it. We need to make sure that we get our apps multi-cloud aware. F5, Red Hat OpenShift, together, we can help you make that a reality. We can make sure that that your users don't have to worry about from which cloud, what URL do I need to go to get this application if it goes down in that data center. We'll help you make sure that they're always up and running and the users can get access to them. And an Istio-based Aspen Mesh delivers consistency across the cloud environments and across multiple frameworks and languages. It gives us the ability to find out where are those problems happening, how can we trace them, how can we remediate them. One thing that Dylan didn't show is the use of experiments. You can go and make changes within the Aspen Mesh environment, look at the portal, make some changes that are not reflected in the environment and see what might happen. And it gives you the ability to fix those. It reduces the mean time to discovery for failure, and in the meantime to recovery after a failure. And with that, we've got Q&A. We've got a few links up here. These are different places you can find the projects that we've been talking about. So the Aspen Mesh project, the controller project, the F5 controllers, and then where you can get documentation.
And I just want to add also, everything that you saw today in the demo, probably by the end of this month, all the playbooks, all of the scripting, all of the configuration, all the quick startup guides, as well as a full architectural document about how we built all this, it'll all be available by the end of the month for you guys to use.
Yay.
Guess we got some work to do on that writing. Thank you, Matt.
I like writing.
Yeah, and if you remember just one link, f5.com/Red Hat, it's a master portal that just contains a lot of what we've been talking about, solution briefs, technical information. If you remember one link from that talk, definitely go there. So if you don't mind, we have mics here in the center of the room, just so your question is captured. No?
Go ahead, and I'll repeat it for you. How's that? Minimum firmware version on the big IP? Yeah. So we were running both with 12.1
And 13.
2 and 13. So we had both versions running in different places.
The only prerequisite is you'll need a best license.
Well, an SDN license.
Yeah, an SDN. Well, in addition, you need the ability to use iRules LX.
Oh, that's right.
So,
Back here.
So you show the diagram where the Istio service mesh spans across different data centers, right? Is that a function of the components that you use above those, like the LTM or TM?
Yes.
Are those the ones that make it happen across data center service mesh?
You want to repeat the question before you answer?
So if I'm understanding the question correctly, you're asking spanning the service mesh functionality across data centers, is that a functionality of the big IP? Yes. The answer to that is absolutely, because it's multiple big IPs, because in order to be able to fail across data centers, you're going to have an LTM to look at your services inside your service mesh, right? So that's where your big IP controller will come in. It's reporting that status out through an iRules and an iRules LX plugin to the big IP DNS server. So we're essentially using fast DNS switching to be able to say, okay, the service has gone down, notify the big IP, and take that DC service offline. So in order to get that level of continuity, you would need the big IP to be able to do that, yeah.
Yeah, so we get the big IP in each. The service mesh, the Aspen mesh, is running one in each of those, in each environment. So that's not spanning all of the environments. So we've got a big IP in each, we've got Aspen mesh running in each, and the big IPs are communicating back and forth with the big IP DNS to give you the URL redirections.